Hi, how is it going? Welcome to Code with Z. In today's video, we're given this linked list that we have here and the number 3 inside of this variable called x, and we gotta go from this linked list to this linked list here. As you can see, the difference is because our x is 3, we're gonna find all of the nodes that are smaller than 3 and make them come before 3 in the new arrangement. As you can see, they all came before 3 because 3 is here, and we're gonna find all of the nodes that are greater or equal to 3 and make those come after the smaller nodes that we have here. As you can see, 4, 3, 5. And when we do this, we have to make sure that the order stays the same. As you can see, 1, 2, 2, 1, 2, 2, and then 4, 3, 5, 4, 3, 5. Now, why are we doing this? Well, because that's what LeetCode 86 partition list is asking us to do. As you can see, it says, given the head of a linked list and a value of x, partition is such that all nodes less than x come before nodes greater than or equal to x. You should preserve the original relative order of the nodes in each of the two partitions, basically what we talked about. Now let's see how we can actually do this. Let me bring this down here. Because we have to access all of these values that we have here, we're going to be looping through this linked list that we have, and then we're going to check the value of each node that we have here with the number that we were given. While we are looping, if we find a value that's smaller than the number that we were given, we're going to add it to our small bucket list. And if we find a value that's greater or equal to the number that we were given, we're going to add it to our big bucket list. And these two bucket lists that I'm talking about are going to be two linked lists that we're going to define. And then we're just going to add these nodes to them. And at the end, we're just going to merge them together, and that's going to be our answer. Now, let's first of all define these two buckets. The first one is going to be our small bucket. As you can see, S, this is going to be a dummy node, and we're just going to have the value of S inside of it because why not? It's representing small. And then we're going to have another bucket that's going to have the value of B inside of it, which represents big. While we loop, we're going to add the values that are smaller than 3 to here, and the values that are greater or equal to 3 to here. Now, because we want to loop through this linked list that we have here, we need a variable called, for example, current, so we can actually know what our current node is. And because we also have to go through these two also need their own pointers. So this one is going to have a variable called CS or current small, and this one is going to have a current big. Now, if something is foggy, don't worry, because you're going to see how this works with your own eyes, because we're going to start the visualization right now. So now we're going to start looping through this linked list that we have here. We're going to grab this value here because we're going to start from here. We're going to be like, is the current value, the value that our current pointer is pointing to, which is 1. Is it smaller than 3? Well, yeah, 1 is smaller than 3 indeed. So we're going to add it to our small bucket, basically like this. And once we do that, we need to move our pointer like so. And the reason we need to do this is because once we add another node to this, we have to know where our last node is, so we can say the next of this node should be the new node. And that's why we need this pointer. After we're done with this, we have to also move this pointer to here because we have to go through all of these nodes that we have here. Then again, we're going to do the same thing. We're going to say, is the current value that we have here smaller than 3? Well, not really. 4 is greater than 3. So we're going to add it to our bigger list or our bigger bucket like so. And then we're going to increment this for the same reason that we just talked about, because we need to know where the last node in our buckets are as well. So we can actually say the next of this node should be, for example, a new node that we're going to find in the future. Now, after we've done this, we're going to also move to the next node here. Then we're going to do the same thing again. We're going to say, is the current value that we have here smaller than 3? Not really. So we're going to add it to our bigger bucket list like so. And then we have to do this again. We're going to move it here. And then same thing for this one. Now, current is pointing to this number, and we're going to get the value again. We're going to say, is the current number smaller than 3? Well, yeah, 2 is smaller than 3. So we're going to add it to our smaller list like so. And then we have to also move this here. Then we're going to do this again. We're going to say the current number that we have currently is 5. Is it smaller than 3? Well, not really. So we're going to add it to our bigger list like so. And then we have to move this here. Again, we're going to move current. We're going to be like, is the current number that we have here smaller than 3? Well, yeah, so we're going to add it to our small list like so. And then we're going to move this here. And we also have to move this here. Now, if we check, the current that we have here is pointing to null or nothingness. That means we're done with our linked list. We've actually went through all of the nodes that we have here. Now that we actually have gone through all of this and we've filled our two buckets, we have to fuse them together. We have to merge them together so we can actually return it. And this is really simple. We're going to say, let me first of all remove this so we can actually have more space. We're going to say, first of all, these are the smaller nodes and these are the bigger nodes. So these come first and this is going to be the end, right? This node that we have here is going to be the last node in our answer that we're going to return. So we're going to say specifically that the last node, the node that our current bigger variable is pointing to, should point to null. So we're going to say this specifically should point to null so we can actually avoid any cycles inside of our linked lists. And then we're going to say these are the smaller nodes, so we know these have to come first. So we're going to say this is the last node in the bucket of our smaller nodes. We're going to say get this node and you can easily access it because of this current small variable that we have here. So we're going to get this and we're going to say this should point to whatever we have here. Basically, we're going to say the next of this node should be anything that comes after our dummy node. So anything that we have here, like so. And if we check, if we actually merge these, like so, we're going to get something like this. As you can see, this is basically the merged version of the thing that we just said. So the next of this should be these. The next of this two should be 435. So the next of this two is 435, as you can see. Now, this is going to be basically our answer. We only have to get rid of this dummy node that we defined in the beginning. So we're just going to return anything that's after our dummy node. And if we do that, that's going to give us all of this here. The next of this node is going to be our correct answer. So we're just going to say return anything that's after our small dummy node, like so, and this is going to be our answer. As you can see, 1, 2, 2, 4, 3, 5, just like we saw in the first slides in the beginning of the video. That's awesome. We're done. So let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we need to do is to define our dummy nodes. So we're going to say const, for example, sDummy for our smaller bucket. This is going to be a new list node with the value of, for example, 0. It doesn't really matter. And we got list node. From here, it's basically given to us by the question, so you can actually define and create a node. And then we're going to have our other node. We're going to say const bDummy to represent our bigger bucket. We're going to say new list node as well with the value of 0, for example. And now we also need to have our pointers. So we're going to say let current s. So basically the pointer for our smaller bucket should be equal to sDummy. And then below this, we're going to have something similar. We're going to say let current b should be equal to bDummy. Simple as that. And then the last thing that we need is going to be our own current. That's going to help us to loop through our list node. So current should be equal to head. That's given to us here. And basically head is the first node in the list node that we're given by the question. And then we have to go through the nodes one by one. So we're going to say while current is not equal to null, keep on looping. And just like you saw on the slides, we stopped looping when current was pointing to null or nothingness. So we're saying keep on looping as long as current is not equal to null. And inside of this loop, our logic is going to be really simple. We're just going to say if current.val, so basically the current value that we have, if it is smaller than x, do the following. Here we're going to say, because it is smaller, we have to add it to our smaller bucket. So we're going to say current s.next should be current, basically. Like so, we just said the last node in our smaller bucket, the next of it should point to current, like so. And then we're going to say current s should be equal to current s.next. Simple as that. And this is basically what we had when we actually moved the pointer by one node ahead. And this is going to basically take care of the scenario where our current value is smaller than x. And then we're going to say else, meaning if the value is greater or equal to x, we're going to have something similar. We're just going to say current b.next should be equal to current, because we have to add it to our bigger bucket this time. And then we have to move the pointer as well. We're going to say current b should be equal to current b.next, like so. Now, after we're done with this is going to basically take care of the scenario where the current value is greater or equal to x. And then no matter what happens, we always have to move current by one node. Current should be equal to current.next. So we always have to move current by one node. Now, after our while loop, we need to make sure that we specifically say the current b, basically the last node that we have in our bigger bucket, dot next should point to null, so we actually avoid any cycles. And then we have to fuse them together. So we're gonna say current s dot next. So basically the next of the last node in our smaller bucket should point to b dummy dot next. So basically anything that we have after our dummy node in our bigger bucket list. And then at the end, we're gonna return s dummy dot next, just like we saw in the slides. Now let's run this and see if we can actually get accepted. This is gonna be all of our code. And moment of truth, I hope I've not made any typos. Awesome. Let me submit this and see if we can actually pass all of the test cases. And let's see. Awesome, we got accepted. Thanks for watching. Don't forget to like and subscribe and keep on coding.